So much of Chapter 3 can be thought of a function toolbox. We spent a lot of time developing your ability to really analyze functions. You recognize the graph of f of x squared, but even if you didn't, you should still be able to use Desmos to find a lot of things. You can use Desmos to find, for this function, you can use it to find the domain. Here it is. This is what it looks like. You can see that you can check that all real numbers are represented here with no breaks. You could still use Desmos to figure out the range, even if you didn't recognize what this function was. You can see that it only has positive y values and y value equal to 0, but it doesn't go down here. So you could figure out that the range is this. You could use Desmos to figure out the increasing intervals. You can see here it's going up from 0 to infinity. All these x values, it's going up, it's increasing, and here on this interval it's going down. You could even use Desmos to compare the graphs of f of x with f of negative x and negative f of x. And we'd be able to see that the function f of x is equal to x squared is in fact an even function. Then using the difference quotient, even though we didn't know what f of x equals x squared was, we could still type it into Desmos, and we could still figure out what the slope of the secant line is, approximately. And if we had a target slope, let's say we had to find a point that had a slope of 1, we could adjust the a and h values. Of course, you want the h values to be really small, but you move the a value until eventually you find a point where the slope of the secant line is approximately equal to 1. And you can record those down. You find another point where m is equal to 0, and record that. Find another point where m is equal to negative 1, and record that. All without really knowing what the x squared function is. You don't need to know what it is, you just need to be able to type it into Desmos. Remember that f of x is the function defined above, so if that's true, if f of fx is equal to x squared, and that if r of x is equal to x, and g of x is equal to 1 over x, then you can find these equations, the graphs and the domains of f plus r of x. Well, that would be just this. This is f and this is r, so add them together and this is what you get. In fact, this is the graph. And we don't even need to know anything about how x squared works in order to figure out that this is the graph and the domain is all real numbers. You could even compose f in g like this. F composed in g of x is f of g of x. And you could replace it somewhat here and combine things. But even if you couldn't combine them, even if you could only take it a step or two, you could still graph f composed in g. And this is what it would look like. It just so happens that here, g of f of x is also going to be a very similar graph. It just so happens to be that f composed in g and g composed of x in this particular case produces the same exact graph. Both graphs have the same exact domain. But if we were using a different function, it might not always be that way. In fact, it probably wouldn't be that way. We could compare the graph of f of x to the graph of y equals 3 times the function x minus 4 over 2 plus 1. That would be a horizontal dilation of 2, a horizontal shift of 4, or a vertical dilation of 3, and a vertical shift of 1. But even if we didn't know how the x squared function worked, we could still just type it into Desmos and let Desmos do all the heavy lifting. All of the demonstrations you've seen so far can be determined graphically on Desmos. In fact, no previous knowledge of the sample function is necessary. Our sample function in this video is f of x equals x squared, but you don't really need to know anything about the function x squared in order to produce any of the above information on it. All you really need to be able to do is type it into Desmos and see what it looks like. Introducing the Mystery Function Project. If you go into Desmos' keyboard, you'll see a button called Functions. You will be assigned a mystery function from this menu. Your job will be to research and investigate that mystery function using Desmos, just as I did with the sample function f of x equals x squared. You will answer specific questions, in fact these specific questions, about your function, just as I did with the sample function. This forms the first part of the project, and it is very concrete and well defined with very right and wrong answers. The short version is this. If you fill out this worksheet on your project, on your function that I give you, you won't be working with x squared, you'll be working with a different function. But if you fill out this sheet, these notes, with your function, then that's the first part of it, and that's most of the project. The last part of this project is more open-ended. You will also be asked to find your own patterns, your own properties, or your own connections with the other functions that you'll find in Desmos. Explore some of those other functions that came from the same menu, from the same keyboard on Desmos. How do they compare and contrast to your particular assigned function? What do you notice about your function that makes it unique? What makes it similar or different from other functions? Find as many of these connections or patterns and properties as you can and talk about them. You'll submit and summarize your findings in a movie of length 3 minutes or shorter. Next up is the rubric. Read it and bring your questions about the project to class tomorrow.